The University of Birmingham is the original British red brick university located in the city of Birmingham. It received its royal charter in 1900 as a successor to Birmingham Medical School and Mason Science College. Figures alone cannot capture the experience of learning and living at the university. Neither can they completely communicate the many elements that make Birmingham one of the most popular UK universities. What they can do is provide a useful profile of what takes place in this institution. In the QS World University Rankings, UOB ranked 62 in the 2013 and 14 rankings out of the top 200, placing UOB 10th out of the 25 Russell Group institutions featured. UOB are consistently top 100 in the Financial Times and Economist Business School World Ranking. Currently it has 5,000 students from over 150 countries, the fourth largest population of international students at any UK higher education institution, and the largest international postgraduate community in the UK. UOB are a founder member of Universitas 21, a global network of 27 research-led universities across 17 countries. The network to be analyzed is the Ring Road. It was chosen because the Ring Road is the major road that connects all the university facilities together. Besides, many motorists use the road for many purposes. The team managed the project through 5 stages. 1. Inventory, where sections and subsections of the ring road were defined. 2. Condition assessment, where the condition of the ring road were analyzed visually and using Merlin. 3. Diagnostic, the ring road was diagnosed visually. 4. Treatment selection, the intervention levels for each treatment were defined. 5. Using KAH. KAH was used to prioritize the maintenance work and calculate its cost. With all these steps, we have achieved an appropriate treatment selection. Many different vehicles use the network daily: buses, cars, heavy goods vehicles, and cyclists. Buses use the network carrying many students to the university for the purpose of introducing it to them. Also, tourists come on buses to visit the British Red Brick University and the museums on campus. Adding to that, buses are used for student group visits to UK's landmarks. Moreover, many students living far from university use their own cars to attend university. Others use the network to attend conferences and seminars. Heavy goods vehicles deliver fresh food to our restaurants on campus daily, serving thousands of students. So, a closure of any part of the road will cause delays to the network users and a lot of damage to business. A road in good condition facilitates vehicles easily, reducing vehicle cost, time wasted, and increased economical benefits. Improved access to hospitals, schools, and markets. Improved comfort, speed, and safety, and lower vehicle operating costs. For these benefits to be sustained, road improvements must be followed by a well-planned program of maintenance. Without regular maintenance, roads can rapidly fall into disrepair. Delayed maintenance has indirect costs as well. Neglected roads steadily become more difficult to use, resulting in increased vehicle operating cost, more frequent repairs, more fuel use, and a reluctance by transport operators to use the roads.
As known, the road is divided into 2 sections, and then each section was divided into subsections of 200 meters. The measurement of sections were determined using the measuring wheel. It was found that the ring road has a length of 1,445 meters. Then the width of each subsection was measured to be used in determining the cost of treatments to be applied.
As noted, the ring road was divided into sections and subsections of 200 meters and referenced as shown on the screen. The ring road pavement is made of 2 materials, the asphalt concrete and block pave. The inspection for potholes and cracks were carried out visually, and they were estimated as a percentage of each section. Wheels and engineering judgments were used to find the percentage of cracking of the road section.
Inspecting the surface condition of the road, so by measuring different types of cracking. So this was the longitudinal cracking by using the wheel machine. So and after that we put the length of the longitudinal cracking in the mapper to know what's exactly the position of the cracking.
The network network had a high percentage of cracks of different kinds, such as longitudinal cracks that occurs at the joint between the adjacent lanes of asphalt mixture or at the edge of wheel path. Low temperature cracking occur when the temperature at the surface drops sufficiently to produce a thermally induced shrinkage. It usually propagates downwards through the mixture. Crocodile cracking is an asphalt pavement distress, most often initiated by failure of the surface due to traffic loading. However, it can be greatly influenced by environmental and other effects, while traffic loading remains the direct cause. These cracks allow water to penetrate into the underlying layers, softening layers that have not been stabilized with asphalt or other materials. Potholes form from fatigue of the road surface, which can lead to crocodile cracking. Finally, chunks of pavement between the fatigue cracking gradually work loose and may eventually be plucked or forced out of the surface by continued wheel loads to create potholes.
In the ring road network of the university, we have discovered visually that there are some cracks on the network which is highly concentrated on the first section of the road. And on these sections, we can also see that there are a lot of trees alongside the road, which might be the cause of this cracking. But cracking is something that is not only based on the trees on the side, but it can also be from the construction of the road. So this could be some materials present in the road construction, for instance clay, that can also cause cracking and may start from the bottom and develop all the way to the surface. It can also be at the surface, but however, these are things that needs to be given serious consideration. At the moment, we have seen that there are different types of cracks, from various types of cracks, from alligator crack, turtle crack. Everything is present on this part of the road. Now, cracks, as for cracks, we don't want to take it lightly because we don't know the extent of these cracks. Because the main reason behind this is that cracks are really dangerous for the road network, because what they do is they absorb the water, or when it snows, this water goes inside the cracks and it penetrates to the road base, sub base and base, and which can cause serious damage to the road, and this can highly deteriorate the network condition.
As the roughness of the road is one of the important defects need to be measured to evaluate the road surface conditions, and this type of defects is easy to measure and doesn't cost a lot. And it can be used as an index to select appropriate type of the treatment, since the roughness affects the road user cost and in terms of the fuel consumption. And to determine the roughness, Merlin has been used to determine the roughness. And before using the Merlin, it needs to be calibrated and the scale factor also to be determined. And Merlin we put the Merlin along the wheel path, and it's quite difficult to locate that wheel path since the road is quite narrow, and some driver need to drive along the middle path of the road.
Graph shows the percentage of surface cracking in the network, with a high percentage of surface cracking as section 2. The percentage of potholes are indicated too, with a high deterioration as section 1. And the IRI is indicated for each section. Map is an overview of the ring road with the percentage of defects measured, potholes, cracking and roughness. Showing a high percentage of potholes as section 1, high percentage of surface cracking and IRI as section 2 compared to the network sections.
What we need to do with this cracking is to apply sealant. We will seal the cracks and then apply surface treatment. In sealing the cracks, we will prevent the penetration of water to the layers, which is causing high deterioration to the condition of the road. With the network here, from the start of the project, the most part of the cracks appear to be surface cracking, which can be sealed and surface treatment be applied to it.
The semi-permanent repair method is one of the best for repairing potholes. It consists of removing water and debris from the pothole, making clean cuts along the sides of prospective patch area to assure that vertical sides of the repair are in sound pavement, placing the hot or cold patch mix material, compacting the patch with a device that is smaller than the patch area. While this repair procedure provides durable results, it requires more labor and equipment than other procedures. Asphalt overlay is necessary when the asphalt surface has reached the end of its service life, or if other methods of restoration cannot repair the roadway. Applying an asphalt overlay requires the following steps: adjustment, lowering of utilities to allow milling machines to traverse the roadway without damaging utility assets, removal, milling of old surface using a milling machine, readjustment, raising of utilities so that they will again be flush with the new surface that will be applied, application of a tack coat to milled surface to serve as a binder for the new surface that will be applied, application of new paving surface by paving machines, application of new thermoplastic pavement markings on a new pavement surface.
Intervention levels are important for evaluating road conditions. According to these levels, engineers will justify their opinion to carry out maintenance work or not. For the ring road, the intervention levels have been considered quite low since the overall surface condition of the road network is relatively good. The main reason is to prevent the network condition become worse and the level of service satisfactory for the users. The threshold value for the ring road are: we consider the 1% for the potholes and 3% for the surface cracking and 4 mm per meter for the roughness.
Using engineering judgment, it was decided that patching to treat potholes will be treated if potholes exceed 1% of the subsection area. Sealing will be initiated when cracks exceed 3% of the subsection area, and the overlay will be treated for the entire section if the roughness is more than 30% and or the cracks are more than 25% of the section area.
Through our consultancy, we aim to do the right work with the right resources, in the right way and the right place, at the right time and the right price. The most important thing for us is to carry an effective and timely maintenance. Doing the maintenance this year will reduce the rate of deterioration and lowers the operating cost for vehicles using the network. Adding to that, fewer maintenance inputs will be needed, and there is potential of reducing accidents on the network because drivers will not have to weave to avoid potholes. After doing our analysis, we found that in Section 1 and subsection 5, 4 and 3, we require thin overlay. Section 2 and subsection 2 in Section 1 will require sealing, and subsection 1 in Section 1 will require patching. It is clear that the ring road network has low traffic, but it plays a major role in connecting all the university buildings together, and many heavy goods vehicles use it daily to supply restaurants and shops on campus. So a small closure of any part will cause delays and loss of money. To avoid unexpected closure and high future cost, especially by knowing the weather in Birmingham wasn't that severe this year, the maintenance should not be delayed anymore.
By using the wheel,
you can see that the condition of the most part of the
Hi Mohammed.
Hi, how are you?
I have a question for you.
Yes, I will do my best to answer.
Thank you.
Yeah, welcome.
So what did you do to measure roughness and the...
1, 2, 3.
As noun. As
1,
noun.
2, 3. How is it?
Yeah, we can count that. Don't just leave me. This is good too. This is good.
Done.
Hey.
Just